Yeah, thank you very much. Let's see if we get a picture here. That would be amazing. Oh yeah, picture worked. Wonderful. So, good evening, Wrocław. This is my very first Ruby conference, and it's amazing that so many Ruby developers actually practice Ruby. I didn't know that. And since this is not the official keynote, but the first talk of the conference, I consider myself now a Ruby developer conference keynote speaker. Cool. So, but I'm not talking about Ruby tonight. I'm talking about something that is programming language agnostic, and that is domain-driven design. So just to get a picture of the room, who here has heard of domain-driven design before this talk? Holy shit, that's almost everybody. That is great. Cool. So, this guy, that's me. I hate these slides. They just show you what you did in your career and nobody really cares. So I love domain-driven design to a very unhealthy degree. And since of today, I can actually make a statement for that. I got up this morning at 4 o'clock. I took a train. I missed my flight. I took the next plane, and I just arrived here 30 minutes before this talk starts. So, and I will leave tomorrow morning at 5, but I will have a party with all of you guys afterwards and talk about domain-driven design for the rest of the night. So, thank you. Applaud me after the beer. But I also started the German domain-driven design community and founded a small conference that is annually in Berlin in October. So if any of you wants to go to Berlin and talk about DDD, learn a lot, and have some hands-on workshops, flyers are here in the entrance, and please join us in October. So let's talk about domain-driven design. To give you a small overview, I want to talk about what domain-driven design is, and especially what it's not, because there seems to be a bit of confusion in the industry. I want to talk about when to use domain-driven design in your projects and who should learn about domain-driven design. We will talk in an example of how you do DDD. We will actually work together to build a small domain and a domain model that we can implement. And then, good weather outside, then we'll talk about why we do domain-driven design and what are the risks and side effects if you do it, because nothing in this world is free. Everything is a trade-off, and even DDD, even if I love it, there are certain cases where this is risky or where you do not want to use it. So, what is domain-driven design? Domain-driven design was a book by Eric Evans in 2003, published in 2004, with a subtitle, Tackling Complexity in the Heart of Software. So this was not about the complexity of technical frameworks, of course. This was about the complexity of the business that you try to implement in working software. He wrote this in a time where most developers were Java developers that worked in business software and did third normal form databases and object-oriented programming, state of the art of 2003. And programmers were really interested in the next framework and the next abstraction and ORM and stuff like that, but not really in the business. So, what we're trying to solve, and what Eric tried to solve with his book, was how can we get this mapping of business people talking to programmers and then programmers looking into code and then translating back and being human compilers and translating to the business people what the code actually does and translating to the code what the business people mean. How can we get this mapping as slim as possible? This is already a best case scenario from 2003, right? The developer talking to the business people. Who's ever done that? Still impressive, but not that many hands. So back in the year 2003, this was really rare. Now it becomes more and more applicable that people actually do that. But usually if you have something like a business analyst in the middle or another team that actually does the design for you and then hands you what you should build and the developers actually implement what they've heard, you have very, very long feedback loops. If you at all can give feedback back to the customers and their needs. So what we want is to have this mapping as slim as possible. And what is the slimmest possible mapping you can get? It's 0. So the trick here is we're going to use a ubiquitous language, which is a funny word. It's ubiquitous language. It's very hard to pronounce, especially for German. But this is something the DDD book does all the time. It's all about language and getting better understanding of your domain. But then you have all these terms that are hard to pronounce or understand. But nonetheless, ubiquitous language is a language that is ubiquitous, means it's everywhere. It's everywhere in the spoken and written form that you have to deal with in your solution of the business problem. Meaning it's in the code, it's in the head of the users, it's in the documentation, but it doesn't come naturally. Ubiquitous language is something that you design, that you develop. So you have your natural language usually, being it Polish, German, English, or whatever your domain people talk. And then you have your business language. If you are in finance, you have special terms that have meaning. If you are in logistics, the same terms can have different meaning. So there is a specific business language that people in the business know and use when they talk about business terms and behavior. And now when you break this down into source code, you sometimes have to find one word for an ambiguous term. Some people say employee, others say colleague, but basically they mean the same, and it's just one term that you can use in code. So what should we actually use as a class name? And this design is called a ubiquitous language. You will have one language in the end that both parties agree upon. When we talk, this means that. So let's define a really clear and crisp ubiquitous language from a domain that everybody knows. This is our living room, and tonight I'm gonna sit on my multi-butt supporter, maybe alone, maybe with some friends, and we're gonna watch some movies on the, how is it called? Entertainment provider system. Cool. Singleton, thank you. My favorite pattern. There's a whiskey called Singleton, but let's get into that later. Yeah, so what's the problem here? This is good code, right? I mean, we've all written code like this. We know what it is and what it does, so let's name it that way. We're done. The problem here is you have a lot of weasel words. There are prefixes and suffixes all over the place that don't add meaning to the domain understanding. It's just describing on a technological level what we find, but we don't care. When we write or read domain code, we just want to see what's the actual business case and behavior. That something is a repository is interesting for someone who develops repositories, but not if I read, hey, I'm using this because I want to get stuff done. Weasel Words is analogy from Shakespeare. Weasel can suck eggs and leave only an empty shell that is meaningless. So there's a lot of weasel words showing up in source code. For example, I don't know if you can see it from up there. Let me read you some. You have the party heads. You have class prefixes like my customer or a customer or the customer. Who am I? What does that mean if I read a class name my customer? You also have the Hungarian notation. This is a Boolean, so let's call it B something something or bool something something. So we know it's a Boolean, right? Well, we have IDEs today that help us with that, so we don't need it actually to understand. And usually if you have written source code and you have your domain behavior sentence by sentence, it doesn't matter what data type is in there. I pay you your salary and you take your salary and take another loan, so yeah, that's fine. You don't need to know that the salary is int or decimal or double. That doesn't matter for the business case. In the case of a bug, you have to write a test that actually checks if everything is all right, of course, but you don't need to read if int salary minus blah, 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 double these. You don't need the technical terms to understand the business value. And we're way not done here. You have philosophers. You have something like the meta or the layer or the super or the obvious prefixes to classes. They only add meaning for the person who actually wrote them. The next person has a very hard time understanding what it actually means. Then we go to the importance. We have the advanced or the general. We have the simplicity, the opposite of the important things. And it doesn't stop there. We go through all the pattern languages. Even in domain-driven design, we have repositories and aggregates. And you have the gang of four patterns like facade and decorators. Who here has ever enriched their class names with the pattern that they're actually using? Now I'm happy that I see all the hands up. So this doesn't add to readability. It's just explaining the next person what you're doing here. But what if you change the pattern that you're using, but the business thing is the same? Then you will change your source code and meaning changes. People now read a different text, but actually nothing in the behavior changed. You just had some different implementation detail at that point. And this doesn't end. You have so many different of those. You can take the slides later and go through all of them, and I'm very, very eager to fight against each and every one of those usages. Up until the point where I say the suffix ID should be forbidden in source code. If I have a customer ID, that's a very bad pattern, because unless it's a domain thing that you actually have an ID that you can show around, you never have a real customer in your source code. The real customer is here outside of the world. In the real world. I am in your shop, I want to buy stuff. But in your source code, you have objects that do domain behavior, and you have representations, and you have information, and sometimes you just have a reference, like, okay, this customer, or the name. So having customer ID never adds meaning from a business perspective. So why would you use it? It doesn't differ. If I have a function and this function needs a customer and some line items that they bought, then I can pass in a customer. It doesn't matter if it's a complex object or it's just an ID. The function will work if I put in the right object. So we try to avoid Weasel words. Let's do it in our source code example. Now the Weasel words are gone. We still have a problem. We actually have two different problems. The main problem we have is we still didn't get more meaning. We just left out some words that weren't adding meaning, but now our multi-but is really weird. The problem we had here is the same term had a technical meaning as well as a domain meaning. It was a multi-but supporter because it supported multiple buts to sit on. And supporter pattern is something technical. And now programmers are all confused, like, yeah, what should I do with those words? If you only use domain terms in your source code, you would not scratch the supporter here because it's actually part of the domain. But is it though? If we just use the words that people actually use in our source code, now we can talk about business. Once I look through the people, oh, my friends are there, let's get on the sofa and watch a movie on the television. Yay, this is how people talk. I'm Scoozy. So I really want to see how people talk in the business in my source code, because then I can reason about it. Then the coherence between what the mental image of the business people is and what my code actually tells them is very high. So when my source code has a bug and the business people tell me, oh, when I do this and then I buy stuff, but when I reject it and then this happens, I can just look into my source code, read the story, I'm like, yeah, this is where it happens, because here are the words they just said. A new programmer on the team can just read the source code, and if you write it really, really well, the domain stories are in the code. So the next person doesn't have to read documentation and source code. The source code is basically your documentation. If you write good tests and you do this with domain-driven objects and function names, everything becomes very, very, very reduced down to the business problem. Let's do an exercise and just raise hands or shout in the room if you have an idea. Something is bad in this code. Might have something to do with Weasel words, might not. So what could we optimize? It's not Ruby, yeah. This is a big problem. This is not Ruby. I should have prepared for that, right? Yes.
For example, we have customer repository and we again repeating the word get customer.
Yes.
Year of the beer. For example, we can refactor to get by year of the beer without again repeating that this is about customer.
Yes. So we have a customer repository and we then say get customer. You could just scratch that. You don't need get customer. So scratch the customer, scratch the get as well. Just customer repository by year of birth. Sounds natural, right? No?
Date time is not a year.
Yes, date time is not a year. That's a very important fact. A date time, the 1st of January 1950 and the 2nd of January 1950 is a different date time, but it's the same year. And we want the year. So what do we do? An int? A year, yes. We just use a value object, which is the low-hanging fruit of domain-driven design. When you want to start with DDD, the first thing you can actually do is just use value objects for every primitive data type you can find. In your domain code, there should be no primitives at all. There is no string in the real world. In some domains there is, but for all intents and purposes, there's not. So, unless your domain is math and you actually have ints and doubles, you only have salary and you have payments and you have height and you have age and names and all those things. There is no string and no int. Whenever you find a primitive, kill it with fire and add a domain type. A value type can just be the primitive data type underneath and then a shell around it, but it makes it explicit. So now you can have a constructor preventing illegal values, and you can have a toString method that gives you beautiful code or beautiful test results, and you have parameters in your functions that tell you what they want. They want a year. Now you can't give it a wrong value. You have to put in a valid year. But there's more. There's way more. Yes? Yeah, That's the easiest thing, right? It's a Weasel word. Customer repository. From the inside, it makes sense. Now we see this is a repository. Cool. But how often are you inside of your classes? You write them, they work, and then you never go back into them until there's a bug. But you always have to read customer repository do stuff. That's not how business people talk. So I want to read customers, and then by year of birth, and then I enter a year. Cool. So I have an interface here. I find customers, and I could have implemented a class customers that has only one method, born in, and it takes a year, and then it returns a list of customers. Cool. The I is a Weasel word, and this is, you are holy Ruby developers. Your code is so crisp and pristine. I come from the very dirty C# world where people still use I for interfaces. And yeah, no. So I come from a world of pain. So if you have to use interfaces, and if in your company culture everybody's telling you, we will not do this DDD, interfaces need an I, just do this. I find stuff. If you don't have interfaces, you're lucky. So customers born in year, that's awesome. The only new thing in domain-driven design is actually that you have one ubiquitous language per bounded context. So what is a bounded context? A bounded context is a semantic encapsulation inside of your domain. There is no natural boundary that is always true. A bounded context is, as the ubiquitous language itself, it's a design thing. If a bounded context is small, it fits in your head very well and you can reason about it easily. But then you have multiple bounded contexts and the interaction between them becomes hard. If you only have one bounded context for everything, there is no interaction problem. You know, it's like a distributed system of ideas. Everything is always consistent, but then if you want to do something in there, you need to understand the whole domain before you can start working. So usually, after some initial modeling, you have a context map of your domain looking like this. We have shopping carts and warehouses and payment and delivery. And each of those contexts has their own ubiquitous language, meaning every term in that language has a specific meaning to that context and is completely oblivious of the rest of the world. Thank you very much. Mama? Okay, so for example, customer. We had customers. All those contexts have a customer. But you would never build a customer class that does all the behavior from all the contexts. Because then, if you add credit cards to your payment system, now you have to test your warehouse again, because you changed the customer class and maybe it's broken. You do not want to couple those things. So what do? We build our own customer classes for all the different bounded contexts. Each customer has only the data and only the behavior they need for that specific context. So in Germany, we have to adhere to the new, in the whole of Europe, to the new data privacy protection law in a few weeks. We built our own bounded context called just customer information or employee information, which holds all the data that don't belong to any behavior. So your name, your address, there's not real behavior. There's no business rules saying if your name starts with P, behave differently. So all those information are just data, and it's its own bounded context. And the only thing that all bounded contexts share about the natural customer or the natural employee is an ID. It's just a UUID or whatever that gets passed around. So my customer class in the payment system has an ID and some data it needs for behavior, like credit card information, stuff like that. But there is no name. If I want to show you an employee or a customer on screen, I just take the ID, ask the information context, get a screen name, and that's it. And when you want to forget that customer, you just ditch that bounded context, and the rest still works.
But you just mentioned that ID
Sorry?
You just mentioned that having IDs are also wrong.
No. I did not say having IDs is wrong. I said putting ID as a suffix in your class name is wrong. So if you have a reference to your customer, I would call it customer reference, because that's what it does, and I would put it as a value type inside of my business object. A good point. So if you do that, if you have your own language and your own name, like customer, for all the different contexts, then you can figure out maybe it's not the real word that we're using here. In payment, you don't really have a customer. You have a creditor and a debitor. So you have actually two different objects with two different names, and it's not the customer at all. And in delivery, you don't have a customer. You have a shipping address. So something goes to the shipping address. They don't care about a customer as a concept at all. The warehouse it doesn't even know that customers exist. It just gets an order and has to put stuff into boxes and then give it to the delivery system. Only the shopping cart might have a real customer with some behavior of, if you bought this, you should also be interested in this, so we will advertise for you. So this is what bounded context does for you. You have your own very unique semantic barrier, and you can reason about every meaning of every word inside of that bounded context. So in your source code, this is usually a namespace or a different project or a different solution. I have actually no clue how Ruby separates projects. How do you do it? Gems? Gems. Oh, sounds beautiful. Yeah. So whatever works, works. So finding the bounded context is important. I'm not bashing Ruby, by the way. I just have no clue. So finding bounded context is really important, also for strategic planning, because some contexts are more important than others. You need all those bounded contexts we've seen before to actually make your domain work. But Amazon would not put the same creativity, people power, and programming efforts into each of those contexts. Payment, you can just buy that from PayPal, or maybe you build a little system yourself, but it's okay. If it just works, it works. If it's broken, you fix it. But it's not your core domain. It's not what makes you better than the rest of the market. So for Amazon, this might actually be the shopping cart context. And the shopping cart context was or is for many years the core domain. What you do with this context map is you define where is my core domain, what is where I put all my power in, and what domains are supporting domains. The supporting domains are specific to your context, so only you can build them, but they are not that important, so you can put your juniors to it or just let them be built in a quick manner. You do a CRUD application, whatever. Payment is something you can actually buy in most cases because there's no specific behavior for payment for most domains. And if you now know what is your core domain, what's supporting, there's a problem. Because, for example, the shopping cart and the warehouse have a relationship. Meaning the real world has a relationship, these two interact, and the programmers also have a relationship. There's a team building the warehouse system, and there's another team building the shopping cart system. And if those teams are not aligned in the same way that the business actually is aligned, there's Conway's law coming through, then you have the big problem of misalignment of needs between the development world and the real world. So if shopping cart is core domain and they say we need more information or we need to change our behavior, they will do that. Meaning that the warehouse always has to react on that, like, oh my god, they changed the interface again. That sucks. If the warehouse people now are sitting in the same office, they can say, look, we have a customer-supplier relationship. You know, you are kind of like upstream. This is the U and D up there. You're kind of upstream from the importance value, and we're kind of downstream. So it's your model. You define it. But please take care of us and don't just change your code. Don't just change your definitions. Talk to us first, because we need time to adapt. Or sometimes it's not a customer-supplier relationship. Warehouse really, shopping cart really doesn't care if there's a warehouse in the end or not. They just do their stuff because the other team is not in Seattle. The other team is on the other side of the world, and we don't really like them, so we don't care. It's their problem. That's also upstream-downstream relationship, but with silos. Yes, this is. Bounded contexts are a good candidate for building silos, and that's dangerous. We're trying to avoid that. But you want to have a silo to put the people that have the knowledge inside of that thing and not worry about the rest. So it's kind of like a pro and cons. It's a trade-off, like everything in software. You know? It depends. So what can we do? When warehouse says I'm downstream, or we're downstream as a team, and they hate us, and they really manipulate us all the time, we just build an anti-corruption layer, which is a simple tool to say there's a little barrier in between, which is a real-world communication thing that we also can build in code. When they change their model, we only have to adjust our anti-corruption layer. But this will talk on the outside to whatever they give us. On the inside, we will have the clean boundary that we can define ourselves. So, that said, there's a whole plethora of communication patterns in the book of DDD, and we're not going through all of them now because it's so much psychology and it's late. But it's super important that to understand that software is not something that exists outside of social context. And social organization of your company can't work without aligned software development, if you do anything with software. So you have a socio-technical context all the time, and you should align your teams and your communication structures with the system that you're actually building. And domain-driven design on a strategic level gives you actually a tool that helps you, after modeling your domain, to align your teams. One team can work on multiple domains, of course, but two teams can't work in the same domain. If I have two separate teams and they get the same domain to work on, now two teams do separate decisions on the same code base and model. That doesn't work. So it's basically one team, or you have a misalignment, to be friendly in words. So, as I just quoted, organizational and technical boundaries should co-evolve. Now that's surprising. It's not just the vision or the business people that define the model, it's also the code. Because this is something that goes from all directions. When we in code figure out, oh, this doesn't work, we have bounded context, the organization said, look, this is strategic, this is important, let's just divide the domain that way. But then you code and you can't fit it in your head. This model is way too big and no programmer actually understands it. So there's a lot of confusion and you always make mistakes as a team. This is a good moment to say, look, the code doesn't fit, we need to split the model. This is actually two different things. And then programmers push back and the strategical planning has to adjust, otherwise they hurt themselves. And you can also figure out, oh yeah, the language sounded really clear when we were talking about it. We were modeling and post-its and everything was cool and we had our little circles and colors. But now that we code, we have a clash of class names and now we see, oh, this doesn't fit. Also pushback. So domain-driven design fits very well with an agile project management style because you need a lot of feedback loops to make it work. Now, to show you how code can look, and this is, it's not only not Ruby, it's also not Polish or English. So I did this on purpose to confuse you. This is German domain code, and you see a language that only consists of shift planning and holidays and stuff like that. There is no primitive data type in there. Everything that you see is enumerations and functions and class names derived from talking to business people and years of painful experience of things that didn't work. But in the end, we pushed everything on the outside. There was primitive data types and technology, and now we have a pure language that we can work with. And this is just a test scenario. You know, this is not running code, this is just a test, but these methods are actually just calling the business code. There is no framework in between, there's no magic happening. But there's something beautiful happening with this code. If you do toString for every value type you have, because now we're using value types, you can say, look, everything that has an underscore should just become a space, so it's readable for humans all of a sudden. And every property you can define, because it's a value type, how toString should look. And then, when you run this test, you get something like this, an explanation of the calculation. It's just the methods that run, they just put out to string, okay, I'm running and this is a decision I've made, so this happened, events come out, and then all the values that change just get formatted in a readable way and put on screen. And this is just a test result where we needed no extra framework for. But now, if your server is running and you want to see what's happening in the business at the moment, you can just put all the console outs to the screen and you can see live what your computer is doing in domain language. This is just a present that you get, it's just a gift on top. If you do domain modeling and every class and every function you have is purely domain language, you can just put it on screen and read the story of what's happening. So, how do we discover bounded contexts like these? There are multiple ways. One clue is the contextual language. This is what we discussed. When language changes, you have a different bounded context. Another one is domain expert localization. If you take different domain experts into the room and you talk to them and you have 3 experts standing over here and they're talking about this and 2 other experts are always here, now you see, oh, there might be 2 different bounded contexts because those people don't mix. Maybe they're working in different contexts at the client. This is never a law, it's always just a good hint. You have data cohesion. Now, information that change together, stay together, so maybe they belong to the same bounded context. Business process steps. Once you have a drafting phase, you know, is an order mutable or immutable? Hard to say. It's both. Talking to different different business people, some will say, sure, you can modify the order, take stuff out again because you can't afford it yet, but it's fine. And then at some point you say, now deliver this to me. So the drafting phase of the order is actually mutable, but after you ordered, it's immutable. So an order is two different things, two different bounded contexts, and the one is mutable, the other not. And the last thing is, when you find a bottleneck, whenever you see some people or some parts of the process are waiting on others, that might be a bounded context barrier. And now you can model the interaction between them and optimize the business flow. So that is DDD basically. You have bounded contexts. In those bounded contexts, you have developers and business people talking to each other, and the language they develop together, they use in all the documents, be it code or documentation or tests or specifications, and everybody learns about the business language. That's what domain-driven design is at its core. What is it not? Well, it's not new. That's a misconception. You know, I mean, 2003 is not new for some people, but it's not even that new. Everything in DDD has been written in other books years and years and decades before. The only one single concept that is completely new is one ubiquitous language per bounded context. I've never read that anywhere else before, but everything else is just a good mix of things that fit together if you want to focus on business behavior. And it's also not hard. Even if it seems like a lot of effort to do modeling, to get business people in the room and talk to them, to actually sharpen your language and refactor your code without changing behavior, just to reflect understanding, that seems like a lot of effort. But in your core domain, you will do that effort anyway. But if you don't model it up front or with the business people, you will do it whenever something breaks. And then you will learn through very many steps that are very painful, and you will never reach that quality in the end. So domain-driven design is not hard, because if you work in your core domain, you have to do it. And without the core domain modeling, without the context map, you can't decide where to put that effort in and where to just leave it be. So therefore, it's no overhead, because you actually need to do it to distribute your brain power in the process. And it's not only for complex domains. Complex domains are the ones that benefit the most from DDD, of course, because then you can harness all the architecture patterns and all the great wordings and modeling techniques. But even the most simplest thing, you build your own video library for your home. Using value types instead of primitive data types makes it immediately clearer. If you return to your project in a year, oh, what was I thinking here? You can read it, because your source code is actually speaking your own ideas in your own language. And domain-driven design is not all of these building blocks. Ever since 2011 or 12, or since DDD became popular, more and more people are running around Europe and giving talks about, hey, DDD is great, you can do aggregates and value objects and entities, and that's not DDD. These are just building blocks. If you live in 2003 and you do Java and you have an SQL database, these are perfect patterns to get started with better domain language. And it's not that they're not useful today. I mean, a lot of my business code is actually entities and aggregates. That's fine. It helps me with DDD. But this is not the sum of things that you can use. It's just a few examples, and whatever technical pattern helps you to get more semantic is the one you should use. So if you can go pure functional reactive, that's fine. Go there. If you have any other kind of methods, event sourcing or whatever, that make your code more semantic, just use them. And therefore, it's also not CQRS and microservices and other architecture patterns. Specifically, bounded contexts are not microservices. Please never confuse them. Sometimes they fit well together, and more often than not, they don't. So, when do you use domain-driven design now? The subtitle of the book was Complexity in the Heart of Software. But what does complexity actually mean? Anyone know this graphic? Okay, yeah. So there was a hand. Yeah, this is a Kinevin framework. It's a frame of reference for complexity. So if you have an obvious problem at hand, you see it, sense there is no beer. Then you categorize, lethal problem, what should we do? But you can respond and say, you bring beer and put it there. It's a simple task. It's an obvious problem that has a well-known solution. You can use your team and delegate. Obvious scenarios, so obvious complexity in your domain, is something that everybody can solve, or that even people without knowledge can just be delegated, and then they can solve it. You have complicated parts of your domain, and complicated means you need to have special knowledge or thinking power. You need people that studied or have years of experience. If you find a complicated problem, you sense it, oh my gosh, the car isn't driving anymore, So now you need to analyze it. You need to understand the matter that you're working with. You need to understand the problem. And after a phase of analysis, you know actually how to respond, and then you can solve your problem. Coming to complex. Complex is when you have systems that interact with other systems, and it's so chaotic and there are so many variables at play that you can't determine the right solution no matter how much you think. One of my favorite examples, specifically in Germany, is tax law. There's like whole libraries just full of books of tax law, and it's an append-only domain. So whenever there's a problem, they just add another book to it, and it gets more complex and has more problems. So when you say, no problem, we can solve it, you know, everybody has an opinion. Yeah, the politicians should just do this and then it's solved. Yeah, cool, let's try that experiment. If we do just this, this problem is solved, but now we have 10 different problems, and then in the end the whole system breaks down. Cool, doesn't work that way. So it's way too complex. You have the fiscal market, and you have the whole economy that interacts, and then you have the banking system, and they all are intertwined, and what do? We can't analyze it. We can sense a problem, and then we can probe it, meaning we have to do small controlled experiments, or small uncontrolled experiments for that matter. You need to do small steps and then analyze what happens. After we did an experiment, we can gather insight, and you iterate on problems that are complex, and after long iterations, you might find a solution that is so obvious in hindsight that you think, oh, why didn't we just think of it the first time? Then you know you have a good model. If you think this is too simple to be true, but it's cool, you have a good model, but you can't think of this perfect model in the beginning. You need to iterate on that. That's a complex domain. So chaotic. I've worked in a chaotic company. Not stating that I am right now because I'm filmed, but well, so in a chaotic company or in a chaotic complex domain, what you can do is you can just act, do anything, and just see what happens. It's not probing, you know. Probing is with a scientific mind. You have a clue of what might happen, and then you just check if it fits out. When you act, it's just like, let's just throw fire in there and see what happens. Oh yeah, it burns, cool. So if you have a chaotic domain or part of your domain, just act, see what happens, and then try to make sense of it in the long run, and try to reform that part into something that is in the other complexities, or just get rid of it, or leave the company. That's your solution. But so you have now 4 different types of complexity. Where do you use domain-driven design? All of them is a good answer. So all of them would be, yes, you can use something of domain-driven design in every kind of domain, but you will not use the whole power of DDD in every one of them. And this is why bounded contexting is so important. So my bounded contexts are either obvious problems, you know, payment is an obvious problem, and there's a solution for that. Or maybe it's complicated, but PayPal made it obvious for us. Cool. So if you have your context map and you can figure out, do we have this type of complexity here, you already know, should I do event storming, big design upfront modeling, Whirlpool design, or should I just stick to some value object and be done with it? So DDD gives you the tools to optimize your development process before you get into a lot of accidental complexity that will hurt you in the end. Now, who should learn about DDD? Obviously, all of the Ruby developers and all of the C# developers of this world. So therefore, programmers, of course. But also the architects, if you have them in your company, and the CTO, and the customers, and a facilitator that helps you moderating your event stormings. So basically, everyone involved in your process, in your business solution process, should learn about domain-driven design. If your customer doesn't know what you're doing, if they don't believe that developers aren't people who sit in a basement and they get pizza and Coke and they produce great code in the end, but they're actually empathic people who care about the behavior of the of the domain, and they try to improve your business process. If they don't believe that, they will not interact with you in the way that you need them to actually solve their problems. So when my customers approach me, it's like, oh yeah, he's a developer. Yeah, I need a table and 2 buttons, please. So how do you help those people? Building them nicer tables and more buttons? That doesn't help. You need to talk to them about business stuff. So there are methods for that. And you need to teach the respective people the certain amount of DDD they need to know to be able to work together to a solution. How do we do that? 3 steps. Now we go through a little exercise. We have 3 steps. The first one is extract the right model And the right model means the model that is able to help actually. You do not extract the real world model. You know, I have a customer. Cool, the customer has dreams and a hair color and different shirts in his, and whatever, drives a car. I don't care about all those information. There are certain information I need for the behavior in my domain. So I extract the right model, be it behavior or information, to be able to help with his business problems. Then I put that model into semantic code. Meaning I define a ubiquitous language and I build my code only in that ubiquitous language. Whenever I figure out I can't, there's something, in this case, and you know, I need to use a framework. Don't do that. Just write semantic code and then secure that code from corruption by influence through any kind of messaging or data layer or whatever you have. I do not want to see any framework calls inside of your domain code. That all belongs on the outside. So these 3 simple steps are the key to success with domain-driven design. Cool, now you're done. Whenever someone comes along and says everything is simple, it's just 3 simple steps, this is very wrong. It's a very simplified model. But the essence of it is very important. And even if I'm a German, this is not a march, this is a dance. So you don't do step 1, extract it, step 2, semantic code, and then framework, thank you very much. No. I do it that way, but you don't, please. What you do is you go through these phases, usually in that order in the beginning, but not necessarily. And then whenever a problem occurs or some learning happens, you step to the next phase, go back and forth and do whatever is necessary to complete your system. So if you learn more about the domain, you figure out, oh, they don't say employee, they say colleague, which is not important for my code. It still works, but now I've learned something and I refactor to deeper insight. I refactor my code to reflect my understanding of the domain. Put it in semantic code. Cool. We changed our data layer from nhibernate to event sourcing. Holy crap. Yeah, we do that, but we need to protect our domain code from the corruption of whatever is underneath. My domain code should not reflect that it's using Hibernate or an event store or whatever. My domain code should only be the methods and classes that I need for domain behavior, so I can write them purely. So, let's do this exercise. Let's extract the right model to be able to help. I invited 2 domain experts and they will describe you their domain. I will give you a minute. What do we do? We drink. That is a good start. That's the best start of every modeling session. Building up some trust and stuff. Yeah, cool. So, but now we drank enough. What do we do? We ask, yes. We extract the model and we ask questions. What is your first question? What is fleep? What does this word mean? We have fleep and fleep juice and plumbers and trumbles and plubis. Cool. I ask them what those things mean. So now we have a glossary. All the nouns are written down and we have a specific definition of what it is. Now we build software. No. This is the initial impulse every object-oriented programmer had in their life. Ask for the nouns. And it doesn't add a lot of value. It's not none, but it doesn't add a lot of value, because if a domain expert explains to me the nouns, they explain from their point of view. So they have a lot of implicit knowledge that they don't know that I don't know. And they will explain to me what a plumbus is in context of all those other words, and maybe I get it, maybe I don't. I will just have another definition that is very complex. Way better is ask for those things. If you get a story like that, and it's very confusing because I don't understand the domain at all, it's like gibberish to me. But they said, oh, this is important because, get into those points. When someone says this is important and they stress it, the reasons are something that you could explore. So they say because the fleep has all of the fleep juice. That's not a reason. It sounds like a reason because I say because, but that is not a reason. Maybe it's some implicit knowledge that I don't have. Why do we need fleep juice? Could we take orange juice instead? Yes, no. What would happen if we don't have enough leap juice? How much is enough? So if someone gives me a story and says, oh, this is important because, and then I get a fake reason, I ask for the real reason. And this is the most simplest thing you can do is play the 5 why game. You know, ask why is it important, and they will tell you, and then you say, why is that important? And you can do that only for so often, you know. If you do it 2 or 3 times and people get annoyed and stop explaining stuff for real. So there are some heuristics you can use. A simple heuristic is go for time frame. If they say this happens, then that, always ask what would happen in an alternative order. Even if this seems nonsensical to you, you are blank, you don't know, you just want to model, and this is heuristic. So they say first this has to happen, then they repurpose it. And then you say, can't they just repurpose it and then the stuff happens? If your domain expert says like, that makes no sense at all, cool, now we're on the same page. But if they say, wait a minute, yeah, I never thought about it, but that would actually work with, so now both learned a little. You learn about the model by shifting the time frame and asking what would happen if this is in parallel or after one another, or if this step doesn't happen at all. And be really aggressive with that. Go for all the things where you think there might be some value here, even if it sounds stupid, just ask the question. Domain experts' emotional reaction will give you a lot of information. Yeah, you're laughing, but this is actually very important. Reading the emotions of people while talking to them gives you more information than the words they say. More is maybe a little stretched, but it will give you a lot of more information that you need. So you have some things sounding like they cut, they do this, they do that. It's not really time they're using here, but it seems like because they told that in that order, it might be in a timely manner. It might be a process, or it might just be a description of things that happen in general. Explore that. You find adjectives and descriptions like a regular old plumbus. What is an irregular old plumbus? And how does a regular new plumbus look like? It's a stupid question. Maybe regular old is just, you know, the phrase for standard. It's just a regular old plumbus. But maybe regular old is a very specific domain term. You don't know that. And more often than not, when we talk to business people, everybody has their own mental model, and the implicit things in your brain and in their brain, nobody challenges them. I hear regular old and I'm thinking, it's regular old, so I don't ask. Try to be the dumbest person in the room when you model, but don't be annoying. This is a very fine line and it's hard to walk, but this is something that you can actually practice. So a good heuristic that works for me well is going 1 dimension higher. Matthias Varese taught me that trick. He said, whenever someone says, oh, this is true or false, is this black or white, always ask, is it really binary or is it a continuum? Is there some gray area? Like, not really, or yeah, of course, and you get more information. If someone says, oh yeah, this is like somewhere between here and there, ask them if there's not one more dimension. Like, always go 1 level up from whatever they tell you, always go 1 dimension more and ask if there's some hidden value behind that. It's always the emotional reaction from the domain experts that gives you an answer. So, can we build software now? We know what's important, and we got the time frame and the process order of things, and now we actually understood what is several. Is it 5 or 50,000, or what do those values mean? And we even have the definition of the nouns. So basically we know everything, right? We don't even know if software can help. Awesome, yes! We don't know what the problem is. So they came to us and they told us a story. Cool. What's the problem? Are they trying to open a new market? Are they trying to improve their plumbers producing software? Are they trying to figure out better ways to make plumbi or whatever? We don't know. We need to find out. So asking the right questions is really, really hard. And I've jumped too fast. Asking the right questions is really, really hard. And this is the most important thing you can ask. But if you ask someone, hey, what's your problem? They will not give you the right answer. So you need some kind of collective modeling techniques. For that, you have in domain-driven, you have event storming, and you have domain Whirlpool and domain storytelling. We will get into those in a few slides. So if we extract a model and we try to put that model into semantic code, this code and the model basically align. So we will model now, and the model should be so dense that we could actually write code from it. But the problem is, when you build software, the whole software development process is a learning process. You learn about the business all the time. You learn about the behaviors, the definitions, you learn about the intricacies and the edge cases. And software is just a side effect that comes out once in a while and that reflects your actual understanding for the moment. But your job as software developers is to provide business value. So where's the bottleneck in this whole thing? Where's the bottleneck in software development? Compilation time. Well, maybe not. So access to the business people. Yes, this is a very, very big bottleneck. But it's only one part of the biggest bottleneck ever. It's a learning. If you don't have access to business people, you can't really learn about the domain. Even if you have access, learning is really hard and it's not measurable and you can't plan it. I can't plan how long I take to learn the domain. This is nothing you can work for a lot. So have a meeting. I stole this graphic from Alberto's book, so please don't sue me. Hi, Alberto. So have a meeting. Put people on a table, in a circle. Let them talk. Nothing smart ever comes from this setting. Because people that sit next to you are your allies. You sit shoulder to shoulder, you can whisper like, yeah, that guy's an idiot, yeah, I know, cool. People directly behind that are opaque to me. I can't see them. I can't talk to them. So there's one person I have a high interaction with, another person I don't talk to at all, and people sitting opposed to me are kind of my enemies because we're like, you know, facing each other. So a lot of psychology goes into this and it's bad. It's really, really bad. And you have something that I can see in this room, people checking out. People take their mobile phone and check Facebook or sit on their computers and their Apples. So people check actually out and don't participate in the modeling anymore. And that is really bad. You lose a lot of collaboration power and you lose a lot of emotional bonding that you need to build good software, build good business processes. So instead of having people just talk the whole day and sit in a circle and do presentations and maybe someone will produce a UML diagram, woohoo, don't let the words vanish. Make them stick. Put the words on sticky notes, and Alberto Brandolini invented event storming for that, which is my favorite modeling method, which is why I have a nice slide for that. In event storming, which is a mixed word of domain events and brainstorming techniques, domain events meaning things that happen in the past tense that you can describe in your domain, something that has value for your business. In event storming, you take the right people, so people who have questions about the process and people who can actually answer them, be it users or domain experts or maybe the programmer that has been in the business for 20 years and knows the business better than anyone else. And you give them a limited amount of time, like 4 to 6 hours, unlimited modeling surface, so this wall couldn't be long enough. Just put paper on the wall and then everybody gets stickies and markers so they can start writing down events on orange stickies and model the process in a timeline, which would look like this, kinda. The benefit from this kind of modeling technique is you have a very high collaboration rate, and I can stand shoulder to shoulder next to you and we can talk about this problem, and once I think, oh, this gets boring or I can't add any more value or I have heard something they said, I can just walk over there and continue modeling with those people. And we're never opposed. I'm never like arguing with you. We stand against a model. And if my idea and your idea don't align, we have two ideas that we can now try to make fit, and we can add a third idea that maybe fixes the whole problem. The great thing here is nobody can check out. You're not sitting around. It's not, getting you tired, because sitting gets you tired. You can walk around and it gives you a lot of energy. And you see when people get tired and actually get decision fatigue after a few hours, you can stop the modeling process. But if you have this whole chaotic way of modeling, you will have all the three phases of a good game storming. There's a divergence phase in the beginning. Everybody's adding stickies in parallel. You have total chaos in the room because there's not one person guiding the whole tour. Everybody is talking with everyone. Whatever they think, it goes on the wall. So you do not lose ideas. It's not the boss that dominates what gets modeled, or it's not the customer that everybody's just agreeing to. If I have a different idea of the model, it's somewhere on the wall. And in the end, or in the process, structures will emerge. Some people will talk about this part, some people will talk about that part. Hey, I can immediately see my context boundaries. Cool. So you will get a picture like this where you have the drafting phase of your shopping cart, and then after the order something gets ordered, and then the payment happened or maybe not, and you can see the whole business process and parts of it and how they interact just in written language. You just use events, and then of course the sources of events. Why did stuff happen? Because I as a customer ordered stuff. I gave a command. or because time happened. Every end of the month, this event starts. And you build your whole business process only in language, but those little post-its from the wall translate directly into source code. Who here has heard of or used CQRS in event sourcing? This is awesome. Cool. So, if you do CQRS and event sourcing, you take your post-its from the wall and you have your events, the orange stickies, and those events exist because a user with information from the real world and a view on the screen issues a command. He says, okay, order shopping cart. And then in your domain, you have behavior, the yellow stickies, the behavior that is from the wall. Okay, if stuff is still in storage and if a customer has enough money, then yes, customer ordered. Otherwise, order denied. And then you can take the stream of events on the one hand to actually propagate your, to rehydrate your objects for the domain, or to propagate them and project them into read models. So whatever information you want to project on the screen, you can just take from the events that you just took from the wall of the modeling. So talking to business people is not about code. It's just about the business process. But if you use a message-driven CQRS event source style of architecture, for example, you can directly take the model from the wall that you just talked about with business people and build your software. And your tests, for example, your tests would look like, given these events happened in the past, when I issue this command, then I expect this event to happen. So you can even take the whole BDD, the whole event storming process, and in the end, gather some BDD tests from there. Or get user stories out of there, because you have the users that issue commands. You can just go along the whole path and write your stories that you just put in code, and it compiles. So this is as close as we can get nowadays to have compilable natural language that actually checks out, and that you, after it compiles and runs, you can put a toString on it, and it goes onto the screen, as we've seen before. So now we extracted the right model to be able to help. We modeled with the business people, we talked to them, they explained what these words mean, but actually we did the process modeling and figured out where's your problem, where's your bottleneck, or where do you try to get more value. And now we need to secure that code that we wrote, that we put into events and commands and messages, and we need to secure it from corruption. So this is the hexagonal architecture from the DDD book, and I hate that word because it always gives people the mental image of a hexagon, and now I made it even worse because I drew a hexagon on there. Forget that that's six-sided. Nobody cares about these 6 sides. The hexagonal architecture is actually just ports and adapters. That's what they meant when they wrote it in the books. So what it says, you build your server architecture, you build everything that is around your domain in a way that your domain stays pure. Your domain is on the highest level of your layer architecture. You don't do database layer, domain layer, and then UI or stuff like that. You say my domain is only behavior and all the things that I need in the language of the business. But somehow, if a command comes in and says, look, fire this employee or order this stuff for this customer, you need to load those objects, right? Or this information. So how do you get those information if a database is not part of your domain? Well, there's patterns like the repository, for example, and this repository would be on the outside of the domain. This would be, can I use this here? Is it like magic? No, it's not. Okay, so this would be like, you see there's some REST interface, you know, the thing on the left bottom corner. So there's REST messages coming in, there's someone sending a command. Then you have this teeny tiny bit on the boundary to your domain, which is the inner circle, and this teeny tiny bit says, oh, when this command comes in, I know I need to load from the repository this customer and this product list, and now I can just call the methods and the domain stays pure. The domain doesn't know how it got rehydrated. So you make your architectural concerns and your domain concerns orthogonal by building a unit of work around it that does all the infrastructure stuff and then just calls the pure functions, the domain purity, and stores whatever happened after that. So this is easy if you just do CQRS and event sourcing, but it gets really hard if you have, for example, a legacy database, which is some kind of third normal form tables, but also a small part of the new software that is event sourced. We did a little trick, and it's dirty, but it's working. I would not recommend it as the single solution, but if you have the same problem, we said, okay, let's just build up our own event store. It's just a table called event store in the SQL database. Now your unit of work can actually use the transaction of the SQL to say, whenever stuff in my domain happens, the new event stuff and the changes in the old tables only happen together or not at all. It has a few drawbacks. For example, you can't say, I can scale this up, because you need to make sure that your event store is always completely in sync with the whole rest of the database, but depending on the size and scalability of your domain, that might be a valuable option. So, your ports and adapters can be any technology, of course. So if you have like REST interfaces, or if you have your own ZeroMQ or RabbitMQ or whatever messaging pipeline, however you get into the calls, doesn't matter. The whole infrastructure decisions can be made again and again, and you can change it again. The domain is the important part. That you can use Kubernetes is nice, but, or if you use Kafka, or I don't know what Ruby people use, the gems and other stuff. So whatever you use, it's always just solving a problem in a technological space. So you want to scale up, cool. But that doesn't change your domain behavior. And in your core domain, that's the most important part. If you're not in your core domain, if you're just in some generic or very unimportant subdomain, you can ignore this pattern. You can just say, let's just scramble the information into the database. We just SQL them whenever you need. That's fine. But in your core domain, you really want to separate your domain behavior from all of the technology, because you want to change technological things without hurting your domain. So, why do we do domain-driven design? Basically, for two main reasons. The main reasons why business people generally do things. You want to mitigate risk, or you want to increase the quality of what you're doing to make some profit. So we do domain-driven design to be able to adjust our teams to our business needs. When we have a strategic map of our own business, we can now say, those people have knowledge, they should work here. Those people are juniors, or they refuse to work in the new technology or whatever. We give them something where they are valuable without hurting them, so we can align our team and our strategical business components so that it works. It's risk mitigation. Domain-driven design gives the business people a tool for risk mitigation, and that is a really, really cool benefit. It's also making the coherence between business language of the customers and what the programmers actually understand and write higher. So when I read the code, I don't have to try to understand, oh yeah, they told me this happened later, but now this should happen. My source code has an array of 200 fields, and if the array option 1 is 0 and there's a null, then now I have to be a human compiler. I don't want to do that. That's a waste of my time, a waste of my brain power. So if I can read the story of the domain in the source code and can actually care about that and improve on that, that's something where I can add value. So code is in harmony with business. We have high internal trust. We know our components work because they are tested on a business level, and we are safe from external influence. We don't care if the message framework is exchanged. I know it doesn't break my domain code. Then it also is really valuable for the programmers themselves. It gives you autonomy, because now you can say, I'm in this bounded context and we work in this bounded context. We don't have to adhere to any rules. This is our core domain. We can design our system as we see fit. Other people in other bounded contexts can choose their own architecture. This is where maybe microservices actually fit to a bounded context barrier. So you can choose your own architecture per bounded context, and you don't have to adhere to some we do it this way in this company rule. It also makes you able to harness your mastery in multiple levels. You can become a master in DDD itself. You can just understand how people work, how language works, how you do event storming really well, how you build better aggregates and all those things. But you can also become a master programmer or tester, or there are so many different layers that we talked about today that you need to be able to do good domain-driven design. So you can become a master in wherever your interests and your capabilities lie. And purpose is something that's kind of like a free giveaway. If you do domain-driven design, you focus on the purpose that you give your customer, the benefit you give your customer. So you actually have a purpose in the domain of that you're programming for. Your purpose is not being a better React developer or being a better Ruby user or being a better C# 7.1 user or whatever. That's not a purpose. My purpose is shift planning for hospitals. I improve that day by day. So you actually have some purpose. And these three things are from David Pink's book, Drive. This is what most people are motivated by. Money is a very bad motivator. If I give you more money tomorrow, you will not work harder. Maybe for a few weeks, but if you actually become better because I give you more money, that would mean you would have worked less than you could now because you were angry for not getting enough money. That's a really weird relationship to have with a development team. So when you actually want to motivate people, you need to give them these three different values. Everyone has a different level there, but this is what motivates people. So these are good reasons to do DDD, but there are risks. And I just have one slide, I think, for that. The risks of domain-driven design that I have encountered so far is hierarchies. Hierarchies is my main pain point. So if DDD comes from the bottom up, the developers said, oh, we went to Marco's talk and he was so entertaining, we want to do this now, cool. Then you try to implement this in your company, but there are people in the middle management who say, hey, look, I have power because information is mine. And if the team does something good, I bring it to the next level. So if I let everyone talk to the customers now and we do like collaboration, this won't work, because then I lose my power. So hierarchies are destined to hinder you in becoming better domain-driven designers. You need to find a way, as if you do agile, you need to find a way to give them job security but not role security. If it comes from top to a bottom, so if the boss says we do DDD now, you have a lot of developers saying, but I've been doing SQL for over 20 years and it works fine. And I had my fair share of painful discussions for over 2 years with an employee, with a colleague, and we were never agreeing. It was just impossible to make them understand why this is important. They always had an answer and a good example of how they can do it better. Up until the point that you actually think, maybe SQL is a solution, but so don't get sucked into that hole. So hierarchies are a problem. If you have hierarchical structures, it's really hard to enforce DDD into the whole company. But if the whole company is not taking part in this effort, the benefits are very limited. Another thing is perfectionism. This is the other side. We as domain-driven designers or as programmers, we want to be perfect. You know, I need to learn everything about DDD, and I will not refactor this code until I actually understood these patterns. And you are not domain-driven designers. You're business solution deliverers. You help business people be better at what they do by giving them software. That's your purpose. Make that better. If DDD helps, cool. If just a part of DDD helps and the rest is not really understood, experiment with it transparently, but that's also cool. You don't have to be perfect. If you try CQRS, it doesn't really work, do something else, it's not a problem. Don't try to make DDD perfect or anything in that matter. Perfectionism is actually frustrating. And yeah, the third thing that frustrates a lot is constraints. So if you have constraints in your company, like for example, you can only use MS SQL, which is a constraint we have because our customers have administrators. They say, we can't backup anything else. This is a printer button. This is how we do backup. And then you're like, okay, I could use Neo4j here, or I could use a get event store or something cool. No, it can't. It's just a constraint, and that's frustrating. It's important to know that when you do something like domain-driven design, you try to change your company. It doesn't just change a bit of code. It changes everything. And if you try to change everything, people tend to work against that. Systems try to stay the way they are. That's just a system effect. And you need a long breath to see it through. So, but if you do, then DDD transforms code and culture, and agile and architecture, and everything in your company. So, if you want to read more about domain-driven design, these are the books that I've read about it. The core book, of course, is Eric Evans' DDD from 2004, which is kind of like a hard read. If you ever start reading it, who has read it, by the way? I mean, you all have your hands up all the time here. Ah, that's not even half of the room. So, the rest of you have some homework to do. If you read Domain-Driven Design by Eric Evans, start at chapter 7 or 8. Don't start at chapter 1. It's something that Eric himself says nowadays. I've written the book in the wrong order. I wrote it for developers in 2003, so he tried to get them at the technical level. He starts with all the patterns like aggregates, entities, repositories, and explains how to do them. That's not the important part. The good knowledge comes in the later half of the book. After you've read that, you can start reading the first half. That's fine, but the later part is a really important part. And this book is so dense that when you read it every 2 or 3 years, you get more and more insights. So it's a very bad book for beginners. I would recommend Domain-Driven Design Patterns, Practices, and Principles by Scott Millett and Nick Tune. This is a book, it's written in the order that I would actually write a book if I had the time and effort to write a book. But it gives you all the strategical analysis ideas and the modeling techniques and some architecture patterns, and in the end, even implementation examples. It's light, it doesn't go that deep, but it's a very good overview about the whole scene, and it's very, very up to date. So you get modern ideas in there from the last 4 or 5 years. If you're a which you are not. If you're a C# developer, Jimmy Nielsen is a nice book. If you're a Java developer, Von Werner is a good book, but you're Ruby developers, I don't know if there's a DDD author there. Maybe some of you will start now writing a book. And of course, Event Storming, which is a lean pub book by Alberto. And because he's very busy doing event storming, he's not very busy writing his book. So it's 80% for over 2 years now, and it's fine. Just buy it on LeanPub and read it. It will never be finished, but it's worthwhile. So, and that's it for today. If you want to hear more about domain-driven design and actually practice it for 2 days, I still invite you to my conference. Flyers are over here, and then I thank you very much.
Thank you very much, Marco. Do you have any questions or comments? Okay.
Okay, so there is one thing that interests me very much. Do you think that there is a correlation between DDD and object-oriented programming? Is there a intersection between those two things?
No, I don't think so. So the question was, oh yeah, microphone, yes, everybody heard. Just to repeat it, no. So I don't think that there's a correlation. It started in the .NET world. It's just where oh no, even Eric started in the Java world. CQRS started in the .NET world. But they started with object orientation because that was a main focus of the programmers in 2003. But you can do functional reactive programming and actor models, and you can do projections in perfect semantic. You can just use .NET F# or Scala in the Java world. Or does Ruby have functional parts? Yeah, Elixir, perfect. It's on the BeamVR, right? So it's on the Erlang system. Yeah, so all those things, you can use them and use perfect semantics. So because you have a function, and the function is just written in words, and it only takes in parameters that are types that are actually function types, value types. So it's not an object-oriented thing. The thing is, whatever you have, be it object-oriented or functional or dynamic or static typed or whatever your constraints are, you can find ways to be more semantic, and whatever helps you to be more businessy and less technique-y, it's the right thing. So DDD is by no means whatsoever focusing on object-oriented programming. It's completely agnostic in that matter. And even CQRS and event sourcing is, by the way, they go more in the functional now than in the beginning, where they were more object-oriented, but everything is possible nowadays.
I see how DDD works in explaining existing business processes and how businesses work. Do you see DDD being as efficient applied to startups when new ideas are being developed on a daily basis?
Yes, totally. When you do startup, you have different constraints and you have to work differently. So what you will not do is, you will not do big process modeling up front and have your immense business story and then write all your events up front, because you don't know how they evolve. But this knowledge that you don't know how they evolve goes into your modeling. What you can do is, you can do an event storming for startups by exploring different startup ideas or different business models. So you have a small wall here for business model A, a wall there for business model B, and whenever we figure out while we model, oh, we actually diverge here, let's not try to converge. Let's build two different models and explore them both. So you get more insights, and then you can plan your small controlled experiment on them. So if you have two business models and you figure out, oh, these might work both, let's implement a prototype. Really, this is what Eric Evans calls the domain-driven design whirlpool, where you say, I have stories in my head, just examples. It might be just a handful. Take those stories and then try to design a model that would solve all those problems, and then code that model in a very rough prototype. That's not meant for delivery. It's just to see if it would compile. And then take the insights from modeling and building and find another use case or another story that challenges the code or the model, and then model again. And then you do this whole whirlpool thing and let it grow from there. Using value types is immediately powerful from the very first second you write anything. I have a customer, I use that word, so I have a class customer. It's just an ID inside, but it's my customer, not my UUID. That's immediately valuable. So yes.
One more question.
Thanks. I was just wondering how to apply DDD in a project where a client is DDD agnostic, and how to teach him to use this ubiquitous language and all this stuff, because actually the client is the domain expert. He has the knowledge about this domain, so he needs to just fit into those methodology.
Yeah. So you have the problem of a client who is a domain expert, and they do not share a ubiquitous language with you, and they do not learn whatever you try to teach them. Okay, that's hard. Well, violence is always an option. No, so what you can do is, yeah, I know, good old days. But what you can do is write your specifications. If you do test-driven development, write them in what you think is a domain language, and then take the test output, print it, and give it to them to check. If they give you new specifications, give them some kind of DSL that they can write without needing to program. Just they see the expression that you allow them. Look, these commands, these events, these are the things we have in code, and then you just have a product, for example. So you have your class name or your method name, buy stuff, and you just tell them, not in technical terms, but this is what we can use. So could you please write me the specification for this next case? Because they come to you and they say, this doesn't work and this should be a different value because this will, and you select, okay, this is very rough. I can't really make code from this. So if they don't collaborate with you, you have to do the work. You give them what you think is right and show it to them. And then they read the code and say, no, this is wrong. And if they never collaborate, you just have to iterate on this, and it's your hard work to do. So then you have to always give it back to them until they say, yeah, this is right. And then you have your business language in code. But that sucks. So I don't have a really good idea of how to influence people that are unwilling to learn. Usually, if they see the benefit, they will learn, and they will see. I mean, this is now something that, defines itself. If you show them that the code is better, and if you show them the product is better because of what you do, and you advertise that, and they believe you, then they are willing to collaborate with you, usually. But yeah,
like kind of the way how to make it. If you will show them that from this meeting they're also learning about new things,
yes,
I will be involved in it.
Yes. So if you can get them involved in an event storming, that's what gets most business people to see, oh, developers are asking good questions. They ask business questions. Amazing. They don't ask me what table I should use. They ask me about the behavior. So yeah, try that.
Any other questions? One more. Okay.
Hi.
Hi.
Do you have any tips for remote teams how to do event sourcing?
Yes,
event storming?
Yeah, no, it doesn't work. So it's a problem. This is a huge problem, actually. Oh, they tried for something. Yeah, and now I'm interested.
So, hi, my name is Jan. I'm the CTO of Zen Cargo, a logistics company, living in London, and we have a remote team of 5 people in India, in Germany, Poland. And we're using real-time board together with video conferencing. Thanks a lot. Hi there. Sorry. So, what we're doing is real-time board is a whiteboarding software where you can collaborate with, 10 people. You have unlimited space.
Yeah.
So you can put post-it notes on there. You see the mouse pointer of everyone actually adding to the white space board. And you can have really like regular people in that space and collaborating at the same time, asking questions, and it works to some degree.
Yes. So we've explored multiple tools. This one, there's also a VR tool called ThinkSpace. If you have an HTC Vive or a Gear VR at home, you can put it on, and then you can meet in a virtual space, and people can just collaborate. And you can also do, there's a website, I forgot the address, something like eventstormingonline.com or something, where you can just move post-its around on your computer screen, so everybody's just virtually on the screen. All those things, and this whole, if you have this big screen, this is like one of the best things you can actually do nowadays. But all those things don't harness the full power of event storming. You lose a lot, and what you lose is very important. It's the ability of being physically in the same room, taking a step back, seeing that 2 people are just arguing over there and just going and talk to them and building small alliances and having discussions in small groups throughout the whole day. That's what makes it really valuable. if you have a domain that's already very good explored, so you did what we usually do, do domain you do event storming co-locally, so you bring people together. But once the big picture model is explored and people have their local model that they work on, remoting is fine. It works a little because you already have a shared context. So if you want to clarify ideas or explore some small ideas, that works. But every now and then you have to bring the people together because only physical context gets you this deep exploration phase. And now this is something the whole DDD community is exploring and working on. So my biggest stick would be the virtual reality stuff, because I'm totally into VR and I love how it feels if you walk around in VR. But the problem is then you need per person an empty room with a helmet, and that's totally weird. So
but even then, like verbal messages are missing. Sometimes
yes,
things, even if somebody is the domain expert,
of course,
staying in one place and just staying like that.
Yes.
This is message which you should observe and react for it.
Yeah, that's what I meant in the beginning when I said the emotional responses tell you more than the actual words spoken. Exactly. This is, in a modeling session, the most important things that come from it is you see people standing, looking, shrugging. All those things are super important because you can act on them.
Okay, thank you once again.
Thank you very much.